Sup? Today we are going to continue our discussion of rational numbers and actually expand it into the idea of rational functions. So just as a quick reminder, if I had two rational numbers, which again remember are any numbers that we can write as a fraction, right? So a over b, where a and b are both integers. Right? If I want to add that to c over b, well, as long as these denominators are exactly the same thing, then we just add them. Right? So that just becomes a plus c over b. Right? So again, 3 over 11 plus 6 over 11, that does give me 9 over 11. All right? And if we have two fractions which have different denominators, like for instance a over b plus c over d, then what we do is we can get a least common denominator by multiplying this by d over d and perhaps this one by b over b. And then that will give us the fraction a times d over bd plus c times b over bd. And since they have the same denominator, now we can add those two together. All right. So for a little example of this, if I had 3 over 7 plus 5 over 13, I can multiply this one by 13 over 13, this one by 7 over 7, and then that will give me 39 over 91 plus 35 over 91, which is 74 over 91. All right, and if you remember when we multiplied two rational numbers together, if I had a over b times c over d, then you just multiply straight across the numerator to get a times c, and the denominator gives you b times d. Right? So here, if I had 5 over 8 times 6 over 11, that gives me 30 over 88, which we can start reducing. Right? Since they're both even, I can divide them by 2 in the top and the bottom to give me 15 over 44. Which, by the way, if you go back at the beginning, if you do that right away, it will make your life a little bit easier. I could divide that by a 2 and that by a 2, and then you can see that the 5 times 3 gives me a 15, and the 4 times 11 gives me 44, right? Which is what we should have gotten. All right, if we want to divide, like for instance, if I had a over b divided by c over d, remember what you do there is you take that second one, and then you flip it and multiply it. Okay, so 9 over 4 divided by 6 over 8 is the same thing as 9 over 4 times 8 over 6, right, which gives me 72 over 24, which if you divide the top and bottom by 8 gives me 9 over 3, which just gives me 3. Is that right? 8, sure. Let's go with that. Right? Because if you go back and look at it, I can divide this and this by a 3, that and that by a 4, and then cancel off that 2 and that 2, and I'm left with 3 over 1, which does give me my 3. All right, so these ideas expand into rational functions. Okay? And a rational function is just a function which you can write as a fraction, but you want to have a variable in your denominator. So for instance, f of x equals, how about x plus 2 over x minus 5? Right? That's an example of a rational function. Okay? I said we want to have a variable in my denominator because what if I just had x plus 2 over 7? Well, if you remember your properties of fractions, I can break that apart and make it x over 7 plus 2 over 7, which is the same thing as 1/7 times x plus 2 over 7, okay? Which is just a line. Okay? So again, for a rational function, make sure we do have some type of a variable down there. Okay? Now, we said before, if you wanted to add two rational numbers, you would just add them together if they have the same denominator. It's the same idea with rational functions. If I had x plus 2 over x minus 5 plus, how about 7 over x minus 5, then I can just add these two things together and put them over the same denominator. Right? and then that gives me x plus 9 over x minus 5. Okay? Or if I had a 3 over 2x minus 1 plus 2 over 2x minus 1, that adds up to give me 5 over 2x minus 1. Right? So if they have the same denominator, just add them like you normally would, which of course leads us to the idea of what if they are not the same denominator. For instance, if I gave you a 6 over x minus 5 plus x plus 2 over, how about x minus 8? All right. Well, we can get a common denominator here. Right? This one I need an x minus 8 in my denominator, so I will multiply the top and the bottom by an x minus 8. This one I need an x minus 5 in the denominator, so I will multiply the top and bottom by an x minus 5. So what's going to be left over is a 6 times x minus 8 over this denominator, and an x plus 2 times x minus 5 over this denominator. Which means now, since we have the same denominator, I can add these two things together. Right? So here is my common denominator, x minus 8 times x minus 5. And up top, if we just look at this first part, if we FOIL that out, we get a 6x minus a 48. Right? And then don't forget this is a plus right here. And then this part, when you FOIL it out, gives you x squared minus 3x minus 10. And then if we clean up that top part a little bit, I have an x squared. Let's see, 6x minus 3x is a positive 3x. And then negative 48 minus 10 more is a negative 58. Right? And then my denominator is x minus 8 times x minus 5. Okay? And if you can, you have to ask yourselves, does this factor? And if so, could it cancel with anything else? In this one, it doesn't actually factor, but let's take a look at one that does. All right, so for this one, let's start off with one which actually has the same denominator, but it'll factor for us. If I had x squared plus 3x minus 2 all over x plus 5 times x minus 2, okay, plus, let's say 4x plus 12 over this same denominator. Okay. What we can do is then put these two things together. Okay. So this will just give me this common denominator. And up top I have my first fraction, my first numerator, plus this second numerator. Okay. And then if we put these together, I have an x squared, a 7x, and a positive 10 all over x plus 5 and x minus 2. Okay. And then if you notice that x squared plus 7x plus 10, that will actually factor. That gives me an x plus 5 and an x plus 2. And then what I could do from here is cancel off these common multiples, and what's going to be left over is just an x plus 2 over an x minus 2. All right, so let's try to find a couple where the denominators aren't the same. So here's one. Let's say 1 over 18x cubed y plus 5 over 27x squared y cubed. All right? And let's think about what the least common denominator is going to look like. If you notice, one of them has 3 x's and one of them has 2, so I need to have at least 3 x's down there. Right? So I'm going to have an x cubed in my denominator. One of them has 1 y, one of them has 3 y's, so I'm going to need to have at least 3 y's in there. And then if we think about 18 and 27, if we think about their least common multiples, The multiples of 18 are 18, 36, 54, 72, and that keeps on going. And then for 27, its least common multiples are 27, 54, 81, and it keeps on going. But we can see right here that 54 is the least common multiple. So the least common denominator is going to be a 54x cubed. Right? So if I have this original statement again, 18x cubed y plus 5 over 27x squared y cubed. In this first term, I need to get a 54 down there, so I'll need to multiply the top and bottom by a 3. And I need 3 x's, but I already have that. And I need 3 y's. I have 1, so I'll multiply the top and bottom by a y squared as well. Over here, I need to get a 54 in the denominator, so I need to multiply the bottom by 2. So I'll do the same thing up top. I need 3 x's. I only have 2, so I'll multiply the top and bottom by 1x. I need 3 y's, and I already have those, so I'm good there. So here's what we've got. In the first one, I've got a 3y squared over 54x cubed y cubed. Then I have a 10x over 54x cubed y cubed. And that adds up to give me 3y squared plus 10x all over 54x cubed y cubed. And if you look at this, there really isn't anything that we can simplify or cancel off. All right, here's another one. What if we had this one? How about 7 over 3x squared minus 6x plus x squared over x squared minus 4x plus 4. Okay. Again, two fractions, different denominators, so we need to get a common denominator. At this point, let's factor and see what we need. The first one, I could pull a 3 and an x out, and I'm left with an x minus 2. For the second one, x squared minus 4x plus 4, that factors into x minus 2 times x minus 2. Okay. So if we think about what we need, the one on the left has a 3x in it, and I need one of those over here, so let's multiply the top and bottom by a 3x. And then this one has 2 of the x minus 2's in it, so I need another one over here. So let's multiply this one by an x minus 2 and an x minus 2. Okay. All right, so let's see where we are next. We have our common denominator of 3x times x minus 2 times x minus 2. And for the first part, if you multiply the 7 out, you get a 7x and a minus 14. And on the right-hand side, you'll get a 3x cubed. So it looks like we have a 3x cubed minus 7x, plus 7x minus 14 all over 3x times x minus 2 times x minus 2. All right, so let's try one more of these. If I had x minus 4 over x squared plus 5x plus 6, and then let's add to that x minus 1 over x squared minus 4. Okay. Remember, we want to find, if possible, the least common denominator. Because if you just use a common denominator, it will still work, but it's going to be pretty big. The way you can find your least common denominator is to work with factors. So let's look at these two terms and try to factor them a little bit. The denominator of this first one factors into x plus 2 times x plus 3. And the denominator in the second one, that's my difference of squares formula. So that's x plus 2 times x minus 2. So it would be tempting to do this. I guess, all right, let's take this first one and multiply it by this denominator and multiply the second one by this denominator. And that will work, but it's going to give you some really large terms in the numerator, and if you try to factor those, it can be a large pain. But if you get the least common denominator, it will make your life a little bit easier. Okay, so let's get rid of those last few terms here. It's better. Okay, so if we think about what we need for a least common denominator, the first denominator has an x plus 2 and an x plus 3. Right? If you look at the second denominator, it has an x plus 2, but it doesn't have an x plus 3. So this one definitely needs an x plus 3 in it. So we'll multiply that one and that one in the top and bottom by an x plus 3. Right? And then if you look at the second one, it has an x minus 2 in it, but the first one doesn't. So I need to get an x minus 2 down there. So I'll multiply the top and bottom here by an x minus 2. And now we finally have our common denominator of x plus 2 times x plus 3 times x minus 2. And then up top in this first part, we had an x minus 4 times an x minus 2. And then it's plus, right, because of that little symbol right there, x minus 1 times x plus 3. Okay. So what we'll have left over is an x squared minus 6x plus 8 plus x squared plus 2x minus 3 all over my denominators. And again, if you can keep them factored, that's great, because it might help us at the end. So up top, if you notice, the x squareds are going to cancel. And then I'm left with negative 6x plus 2x gives me a negative 4x. And then 8 minus 3 is a positive 5. And then that's all over my denominators. Okay. And then from here you can see nothing factors, nothing cancels. So that's the end of that one. Okay. All right, well, let's move on to multiplication and division of these things. If I had any rational function, let's say x plus 1 over 3x times x minus 2 times x plus 6. Remember, the way you multiply fractions together is you just go straight across the top and straight across the bottom. Right? So this is going to give me the fraction x plus 1 times x minus 2 and a 3x times x plus 6. Okay? If you can, you may want to simplify before you actually multiply it out. What if I had an x plus 2 over an x squared plus 6x times, how about x plus 6 over x squared minus 4? Well, how do these factor? X plus 2 doesn't do a whole lot, but x squared plus 6x, I could factor an x out of both of those and have an x times x plus 6. Up top, again, the x plus 6 doesn't factor, but x squared minus 4 factors into x plus 2 and x minus 2. Right? And now, instead of multiplying it out, let's cancel off these common terms of the x plus 2's and the x plus 6's, and then we're pretty much done. Right? So that would leave me with a 1 up top, and then down below that's just x times x minus 2. Right? And that is much easier than what we would have done if we tried to multiply it out right away. Because if I tried to multiply it all out, I'd have x plus 2 times x plus 6 over all this stuff. You know, we're going to have something of degree 4 in the denominator, and it's just going to be kind of ugly to try to factor. Right? But by factoring first, it made this actually a fairly easy problem. Dividing by rational functions is again the same thing you do as you divide by rational numbers. So if I had x plus 3 over x plus 1, that rational function, over this one, x plus 6 over x plus 7, then remember, a fraction is just a division problem. So this is the same thing as x plus 3 over x plus 1 divided by x plus 6 over x plus 7. And if you remember, when you divide by a fraction, what you wind up doing is taking the reciprocal, flip it over, and multiply. Right? And if you go straight across, we'll have x plus 3 times x plus 7 over x plus 1 times x plus 6. Okay? So that one's not too bad. What if we have this in a fraction form in terms of a compound fraction? Right? So if I had a 2x plus 6 over x minus 7, right, over, let's see, how about x plus 3 over x minus 8? Okay. Well, again, what we can do is write this out as the numerator divided by my denominator. And in this case, if I just flip it and multiply, it's going to look like this. Oh, just kidding. So it's x minus 8 over x plus 3. And remember, if you can, factor. Right? So here, I'll have a 2 times an x plus 3 times an x minus 8 over an x minus 7 times an x plus 3. Right? So since we factored it and didn't multiply it out right away, we see that we can cancel off those common multiples, and then what I'm left with is just 2 times x minus 8 over x minus 7. All right, so this is what we're going to be working on Monday. We'll do some addition of these things. We'll do some multiplication, division of these things as well. We'll have a whole bunch to do to get caught up. Hope you guys have a good weekend. I will see you hopefully on Monday.